Well, if we talk about errors, x is exact value. For example, pi is equal to 22 by 7, I mean 3.1415926535. So approximately we'll take it as 3.1415. So if we just take the difference, we call it as error. There are different types of error. First one is absolute, meaning if we just take the magnitude, we call it as absolute. Now relative, we'll just divide it by the actual value x, then we call it as relative error. If we just multiply by cent, we call it as percentage error. Inheritance error, if the error is there in the past, we call it as inheritance error. Round of error, meaning just chopping off the error. So we have different types of rounding off the error. The first one is discarded digit greater than 5, meaning if your value is 0.3756, the last value, I tell that up to 3 decimal places it is fine for me. So the last value is 6, so it is greater than 5, so I'm just taking it. If it is less than 5, then we'll not add one more for that. If it is equal to 5, if the previous number is even or 0, we'll not add it. If the previous number is odd, then we'll add 1 for that. Now truncation of errors, meaning accumulations of errors, like how it happens. As of now, e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorials and all that. As of now, as a finite digit, I just may fix up to 3rd degree or 4th degree. So what are the values of others? So that will accumulate as an error. Like that, how much the maximum error can accumulate? The maximum error can truncate. It says that if I'm looking up to 4 decimal places, then I'm okay with the error of plus or minus 0.405 into 10 to the power minus 4, meaning 4 decimal places I'm taking it as n. So I'm okay with plus or minus 0.5 into 10 to the power minus n of maximum error. Now, how the errors can be seen in series? We can express e power x, sin x, log x, cos x and all in terms of series, meaning e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial and all that. So if I'm restricting up to 4th degree, then after that I'll give the name for that as Rn. Rn will be the remainder, I mean that will be the error for me. So Rn is equal to x minus a all to the power n plus 1 divided by n plus 1 factorial into the derivative, the n plus 1th derivative of the function at the value a. So I'm giving another name as m. So m is equal to, it is just n plus 1th derivative of the function at the value a. That's all. Now these 4 problems are pretty much straightforward. You need not to worry much on this. If you want to express in terms of 10 to the power minus 4 and all that, avoiding some decimal places, you can write in that way. Even otherwise, if you want to write directly as 0.000 something 965 and all that, even that is also fine. It's your choice. The problems are straightforward, just to find absolute error, relative error, percentage error and all that. So you can check all these 4 problems. Now, we are supposed to obtain the approximation for the function f of x is equal to 1 plus x all to the power 1 by 2. 1 by 2 means root of 1 plus x also. Up to 2nd degree we are focusing. After that, whatever it comes, that will be the error for me. Meaning I'm just ignoring it, even the value is there for that. So what do? I'm just expanding it using the Maclaurin series. I know the formula of Maclaurin series. F of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial f double dash of 0 plus x cube by 3 factorial into f triple dash of 0. So that x cube by 3 factorial f triple dash of 0, we are just ignoring it. So let's check the value of f of 0, f dash of x, we'll find it, meaning we differentiate it. Then we'll find f dash of 0, then f double dash of x, then we'll find f double dash of 0. We'll put the value. Now this 3rd value will be the error for me. For that only it is not required. We are finding what will be the value as a error part, meaning we are just ignoring it even if it comes. Using this Maclaurin series, we need the value of 1.05, meaning at x is equal to 0.05, meaning 1 plus 0.05 root, meaning the power will be half. So root of 1.05 will be equal to approximately 1.02469. Now we'll check how much are we ignoring, meaning R3, we'll put the formula, we'll write x is equal to 0.05, we'll substitute everything, we'll get it. Now R3 is equal to 7.8125 into 10 power minus 6. If you want to express in terms of 10 power something, you can express, otherwise 0.00 something and all that 78125 can also be fine. The second problem says like this: the value of log 1.1 is computed by using Taylor's expansion of log 1 plus x, meaning what will be x? X is equal to 0.1 up to the term containing fourth, x to the power 4 means it will be of fourth degree, to which place of decimal approximation is correct, meaning we are finding n. Okay, so the Maclaurin series goes like this. I have written it. F of x equal to log of 1 plus x is given. So we are supposed to find f of 0, f dash of 0, f double dash of 0 and all that, and we have to find it. So up to fourth degree we are fine. Then after that it will be error for me. Now I put everything in my function, I mean in my Maclaurin series. So f of x, meaning log of 1 plus x is approximately equal to x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4. Now what are we neglecting? The next term we are neglecting. So it will be, the magnitude of that value will be x to the power 5 by 5. Okay, it is the expansion. It is my R5. So the condition to find n, we are using maximum truncation here, meaning this x to the power 5 by 5 is less than 0.5 into 10 to the power minus n. What will be n here? N is 4. Up to fourth degree I am seeing. After that it will be error for me. So it clearly says that the next term, whatever the error we are telling, meaning Rn, meaning R to the R5, x to the power 5 by 5, it should be lesser than 0.5 into 10 to the power minus 4. As I've already told you, at x is equal to 0.1 only we are finding, meaning log of 1.1. So as of now, we have the expansion of log of 1 plus x. So we just take the value x is equal to 0.1. So as of now, I'm just checking how much will be my error. So x to the power 5 by 5 is equal to, I'll just substitute my value. So I'll get it as 2 into 10 power minus 6. I mean, we know that the error should be lesser, meaning 2 into 10 power minus 6 should be less than 0.5 into 10 power minus n. What will be n here? We are supposed to find that n now. So as of now, 2 into 10 power minus 6 is less than 0.5 into 10 power minus n. So I cannot compare 2 and 5. So what do I say? That 2 is less than 5. So I just take that 2 into 10 power minus 6 is less than 5 into 10 power minus 6. So I'll just equate that to the place of 2. I just take 5. So you just compare on both the sides. So 0.5 into 10 power minus 5 is less than 0.5 into 10 power minus n. However, I want to compare the value like that. I'm fixing my LHS. So n is equal to 5. It is straightforward.